graph the function f of x equals 3. Well, that's telling us that y is always 3. So the graph of a function like this would look like a horizontal line. Sure, my markers are going dead here. A horizontal line at 3. Here it is. Here's our graph. Now, bonus question. What is the derivative of this constant? Well, we're looking for the slope of this horizontal line. Remember, the slope of any horizontal line is 0. So we have a constant slope here. The rise over run at this point is the same as the rise over run at this point is the same as the rise over run at this point. And we have a constant slope. So any m tan would be the line itself. And we'd say the slope of the tangent is 0. Constant, derivative 0. Notice, for derivative, I said m tangent. That's what the derivative is. You can see graphically. The slope of any tangent line would be the line itself, and we'd say the slope of a horizontal line is 0. The derivative of a constant is 0. Here we're asked to graph the function f of x equals -2. It's telling us y is always -2. No matter what x we plug in, y will be down here at -2. That's a horizontal line at -2. There it is. Here's the line y, or f of x, equals -2. Now the slope of this line is 0. There, or there, or there, or any place I put my x. Any place I choose to put my x. The rise over run is 0. So if I asked you, what is the derivative of this function? You'd say 0. Remember, that's the same as the m tan. And any tangent to this line would be the line itself. And it has a slope of 0. So a constant has a derivative that is 0. It doesn't matter if our constant is 3 or -2 or a big number like 100. If I graph y equals 100, if I choose my x here or here or here, this line is going to have the same slope. The slope of this line is 0 because the rise is 0. Rise over run is slope. So our derivative here, this is a bonus question, our derivative is 0. The derivative of a horizontal line is 0. If you have a constant, its derivative will be 0. Y equals 3x. Graph the function, all right? Not a hard problem. We know y equals mx plus b. We have a rise over run of 3 and a y-intercept of 0. The graph will look something like this. Now, at any point, I'm going to go rise 3, run 1. Rise 3, run 1. The slope is constant. So if I gave you a bonus question, I said, don't just graph it, but find the derivative. Well, the derivative is 3 because that's the slope of the tangent, m tangent. And if we do a tangent of the straight line is the line itself. So we'd have to say that the slope, the constant slope, always going to be 3 over 1, means that our derivative of a linear equation, linear means we have an exponent of 1, is going to be just a constant. It's going to be that coefficient of your linear term. 3x means 3. Graph the function, find the derivative. Well, y-intercept, y equals mx plus b, b is 0, the slope is -2 over 1. It's going to look something like this. So it will give us a line like this, and notice the slope is -2 over 1. No matter where I look, the slope is constant. So our derivative will be the slope, f dash of x, because we have a constant slope. We could say our tangent line would be the line itself. And what is the slope of it? It's -2. Notice a linear graph or linear equation is going to have a derivative, our m tan, that is just the coefficient of the linear term. If we were asked to graph y equals 2/3 x, well, that's rise over run, y equals mx plus b. Our b is 0. So we know that our graph looks something like this, going right through that origin there. And the slope anywhere is up 2 over 3, rise over run. Up 2 over 3, rise over run. Notice positive slopes go up and to the right. So if I said, what is the slope, m tan? We'd say the derivative here, another synonym for m tan, or the slope of the tangent, is simply 2/3. Notice, linear graph, the slope will be the coefficient and the derivative will be that slope because it's constant. We are slowly but surely working our way to get to the power rule. We have not seen the power rule yet, but we have seen the derivative. That's how we read this. D dx of a constant k is 0. For example, when y equals 3, we said dy dx, the derivative was 0. D dx of kx, we read this as the derivative of some constant times x is the constant. For example, if y is equal to 4x, we said dy dx is 4. So here is the rule, here's how it plays out. Here is the rule, here's how it plays out. We've just learned this, and here are the rules as we can see them and memorize them or know them. If we're taking the derivative of a constant, we get 0. If we're taking the derivative of a linear term, we get the coefficient of the linear term.